All right, guys. So we're going to talk a little bit about classification today. So, taxonomy is just the science of classifying things and putting them into an organized, logical pattern. We can put things, new organisms, into categories, and we also provide a name for them. So, Carl Linnaeus is the father of taxonomy or classification. Divided organisms based on their structure solely. Now, interesting part about this is a lot of these organisms that he classified and put into categories, the taxonomy that he put them in actually holds true even today. Now, there's been some modifications due to genetic testing and things like that, but by and large, most of the organisms that were put into certain categories stayed in those categories. And it is a two-part naming system, binomial nomenclature. So bi, two, nomenclature just means naming. All right, so 2 words, all in Latin. Why? Because it is a dead language, meaning that it is not changing. Therefore, I could have a conversation about a organism with somebody in China, and they would know exactly what we're talking about because we're not using common names, we're using scientific names in Latin, which are not going to change. The genus is always capitalized. The species is not capitalized, and it must be underlined or in italics. Now, if you're writing it on a test or something, underline it. If you're typing it up, you can use italics. All right, so Homo sapiens. All right, Homo, which is the first one, which is our genus. All right, so it is capitalized. And the second portion is sapiens, which is the species name, so that's uncapitalized. And you can see we've underlined it here. Linnaeus also came up with a organizational system for putting them in groups and things like that. So he calls these taxa, or these taxon, and they fall into certain categories. So let's look at the categories. There are 8 levels of taxa, all right, and we're going to talk about each. All right, so first one is domain. This is the widest and broadest. So they go from most broad to most specific at the bottom. Kingdom, phylum, class, order, family, genus, species. Okay? So domain being the broadest, there's only 3 categories. Then we get into kingdoms like plantae, etymia, things like that, phylum, class, order, all the way down to the last 2 here are going to be what we name them with, the genus and the species. So some ways to help remember this is, did King Philip come over for great spaghetti? Okay, you will need to know these in order. So one of my favorites from back in the day was, do kings play cards on fat green stools? Like I said, whatever you need to help you remember it. These are just some examples, but you will need to know these in order. All right, in classification, we use things called cladograms. Okay, we also use things called dichotomous keys. We'll talk about both here. Okay, so a cladogram is just a diagram that helps us see the evolutionary relationships between groups of organisms or individual organisms themselves. Where we get the dividing points, or where they kind of split, and we'll see that in a minute, is that they're derived characteristics. This is a characteristic that appears as part of the lineage, but it is not in the other members of the organisms, the animals that we're classifying. So here's an example. So we start off way down here with just vertebrates, meaning they have a backbone, a notochord. All right. If we look at this is a bony skeleton. So everything above here is going to have a bony skeleton. Everything below here is going to have a non-bony skeleton. So sharks. So if we look at 4 limbs, so once again, everything below here is not going to have 4 limbs. Everything above here is going to have 4 limbs. So if we're talking about a bony skeleton and a vertebrate, we would be talking about like ray fin fish. If we're just talking about vertebrate, we'd have that. If we're talking about has 4 limbs, has a bony skeleton, and has a vertebrate, we would be talking about like amphibians, primates, rodents, crocodiles, birds, all those kind of things. All right. So here we have one. let's see. Here's our derived characteristics right here. Okay. So let's see if we can organize these into groups of organisms. Okay. So we start between A and B. So B, no legs, legs. So we would just put legs. Okay. So this first one right here would be like segmented bodies. Just means their bodies have different sections. So if we look, each one of these bad boys have a segmented body. So that would be down here at A. All right, so legs, segmented bodies, legs. Now what's going to divide these guys from these guys? Let's look. Do we have jumping legs? Kind of, sort of. Legs in general, we've already used that one. Curly antenna. Nope, not yet. Jumping legs, wings. All right, we could probably go and put wings in here because everything above this one has wings. All right, and if you notice, these two have two sets of wings, so double set of wings. Okay, so cross that bad boy off. All right, cross wings off. All right, and we can do right here. We have curly antenna. All right, so we got curly antenna. All right, now we can go back to here where we were. There we go. So here we have 8 legs, and if we count here, you kind of hard to see under the butterfly and dragonfly, but here they will have 6 sets of legs as well. So C is going to be 6 legs, not 6 sets. Sorry, 6 legs. All right. So then we come up here and we see we have a little bit of a branch here, right? So let's see what we got left over here. We got jumping legs, and we got crushing mouth. So these bad boys, obviously, since the grasshopper, are going to have jumping legs. Cross that off. And then here we have these bad boys down here are going to have crushing mouths, meaning they gnaw up their food. So we can see we can divide up these things on these derived characteristics. So they kind of put them into categories. And this is what we do in classification when we're classifying organisms. If it had a curly antenna, a double set of wings, 6 legs, all right, we would know it probably belonged in the butterfly genus. We're not 100% sure which one it is. We don't necessarily know the species per se, but we can put it in a category nonetheless. All right, so let's try to create our own cladogram. So first look at the animals, study each, and establish which characteristics they share or don't share. Okay, and I'll give you a second. I'll pause the video. All right, so now that you've kind of done your own thing, figuring out which is which, let's go through it. Do they all have cells? Yes, they do. Okay, well, we're going to do it this way. So we'll go one by one. Slugs. They have cells, no backbones, no legs, no hair, no opposable thumbs. Catfish. Cells, yep. Backbone, yep. Legs, nope, so they don't have anything above that. Frogs. Yes, cells, yes, backbones, yes, legs, no hair or thumbs. Tiger. All right, yes, cells, yes, backbone, yes, legs, yes, hair, definitely no opposable thumbs. Thank goodness. If tigers get opposable thumbs, we're screwed. All right, humans, cells, yep. Backbone, yep. Legs, yep. Hair, yep. Opposable thumbs, yep. Okay. So now if we're going to try to create a cladogram on these, all right, let's see what we would get. So once again, pause the video, try to create your own cladogram, and then we'll check, see how you did. All right, so we got our derived characteristics. So just starting off with cells. Once again, everything above this has cells, everything below it would not. Backbone. So boom, everything above this has a backbone, everything below this does not. We got legs, hair, last but not least, ye old opposable thumbs. Helps us pick up stuff. We like them. All right, another method of classification is a dichotomous key. Okay, this is where you're going to have a list of characteristics and you're going to see which one fits in. If it does fit in, it may say go to like 2, and I'm going to show you a picture of this so it'll make a little bit more sense. Like go to 2 or go to 5 or da 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 da. But this is if we're out in the wilderness and we have a dichotomous key, we can easily identify what organisms are around us. So here we go. Example, and we'll be doing this in a lab. So you're going to have different types of candy. And we're making these up as we go along, but you know, this would be like if we were doing saltwater taffy, Saltius taffinia. Okay, so is it chewy or is it hard? It is chewy. All right, so we're going to go to 2. Is the candy wrapped or is it unwrapped? Okay, it is wrapped. If you've never had saltwater taffy, go to 3. So we go down to, oops, sorry about that. So go down to 3. Is it round or not round? Okay. You know, this one kind of gets funny. So you can see it as round or not round. I can see either way, but by and large, saltwater taffy is round. So we're going to go to 4. Is it wrapped all in white? And then you would have saltwater taffy. So if we did like a Star Crunch, I'm going to guess this is Starella explosivus. All right, we'll go up to here. Is it hard or chewy? It is chewy. Is it wrapped? Yep, it's wrapped. It's not necessarily round, so we're going to go to 5. Is it brown or in white or not brown and white? And it's not brown and white, so we're going to go to 6. Is it wrapped in silver? Is it wrapped in various colors? It would be wrapped in various colors. So we're going to be making one of these along with a cladogram of the different types of candy that we'll have in our lab. Okay, so as always, if you have questions, please bring them in and we will go over them.